Why doesn't the UK so far north freeze like Siberia? The answer isn't just in the clouds or winds, but in the deep moving waters around us. Ocean currents, vast, powerful rivers beneath the sea, act as the planet's climate regulators. For Britain, this means mild winters and green landscapes, thanks to a warm current traveling from the Gulf of Mexico. Without this oceanic central heating, our climate would be far harsher. Every second, more warm water flows toward us than all the world's rivers combined. This hidden oceanic engine shapes our weather, agriculture, and even our culture. Understanding this connection between sea and sky reveals the delicate balance that makes our home habitable. The story of the UK's weather is, at its heart, a story of oceanic journeys and the warmth they deliver. Ocean currents are like massive, slow-moving rivers within the sea, winding their way across the globe with a silent, relentless power. Though invisible to the naked eye from above, these currents shape the very fabric of our planet's oceans, guiding water on epic journeys that span thousands of miles. They follow invisible paths set by the sun's heat, the persistent push of the wind, and the steady turning of the Earth itself. These forces work together, creating a complex and ever-changing network of currents that connect distant corners of the world's oceans. Warm currents, born near the equator where the sun's rays are strongest, carry precious heat northward and southward toward the poles. As they travel, they warm the air above them, influencing weather patterns and making distant lands more temperate than they would otherwise be. Meanwhile, cold currents flow in the opposite direction, returning chilled water from the polar regions back toward the equator. This constant exchange helps regulate the planet's temperature, acting as a global thermostat. This vast, interconnected system is known as thermohaline circulation, a global conveyor belt powered by differences in water temperature and saltiness or salinity. It's a process both delicate and powerful, quietly shaping the world beneath the waves. As warm water travels, some of it evaporates under the sun, leaving salt behind. This makes the remaining water heavier or denser, especially as it cools in northern and southern seas. Eventually, this dense water sinks, plunging deep into the ocean's depths. This sinking, salty water powers the deep ocean currents, creating a continuous loop that moves not just heat, but also vital nutrients and oxygen throughout the world's oceans. These deep currents are slow but unstoppable, taking centuries to complete their journey. For centuries, sailors and explorers have relied on these currents, using them to cross vast oceans and discover new lands. Yet, only in recent times have scientists begun to truly grasp the immense scale and importance of these oceanic rivers. Ocean currents are the arteries of the sea, sustaining marine life by transporting food and nutrients and shaping the climate of entire continents. Without them, life in the ocean and on land would be very different. For the UK, one particular current is especially crucial, a river of warmth known as the Gulf Stream. This powerful flow of water brings mild winters and lush green landscapes, defining the climate and way of life for millions. Let's follow that current's journey and discover how it shapes the world around us. The Atlantic Meridional Overturning Circulation, or AMOC, is a vast conveyor belt, stretching thousands of miles across the Atlantic Ocean. This powerful system is one of the most important drivers of our planet's climate, quietly shaping weather patterns and temperatures across continents. Imagine a massive, invisible river within the ocean, constantly moving water, heat, and nutrients from one part of the world to another. This conveyor belt moves water through the Atlantic, creating a continuous flow that connects the tropics to the far north. It's not just a simple current, it's a complex, multi-layered system that operates both at the surface and deep below. At the surface, warm water flows northward, carried by currents like the Gulf Stream. As it travels, it gradually cools. Meanwhile, in the far north, cold, dense water sinks and returns south along the ocean floor, creating a deep, slow-moving undercurrent. This constant exchange is what keeps the system running. The United Kingdom sits right in the path of this northbound warmth. Thanks to the AMOC, the UK enjoys a much milder climate than other places at similar latitudes. The journey of this warmth begins in the tropics, where the sun's intense rays heat the sea. Here, the Gulf Stream forms, gathering up this tropical heat and carrying it up the east coast of North America, past Florida and the Carolinas. As the Gulf Stream moves north, it eventually becomes the North Atlantic Current, which then spreads this precious warmth across Western Europe. This is why cities like London and Paris are far warmer in winter than cities at the same latitude in Canada or Russia. This current keeps our western shores much warmer and greener than their latitude suggests. Without it, the UK's winters would be far harsher, and its landscapes much less inviting. Prevailing westerly winds pick up this oceanic heat and deliver it straight to the UK, especially during the cold winter months. These winds act like a giant natural heater, moderating temperatures and bringing moisture that shapes the British weather. Far to the north, the water cools dramatically, becomes denser, and sinks deep into the ocean. This process, called deep water formation, is what drives the entire circulation system, pulling more warm water northward in a never-ending cycle. This sinking action is the engine that powers the AMOC, drawing warm water from the tropics and sustaining the cycle that keeps our climate stable. Without this mighty conveyor belt, our climate would be unrecognizable. The UK could face winters as cold as those in Canada, and the lush green landscapes we know could be replaced by icy, barren scenes. The AMOC is truly one of nature's most remarkable and vital systems. To truly appreciate the power of the ocean, let's compare two places you might not expect: London, England, and Labrador, Canada. Both sit at almost exactly 51 degrees north latitude, meaning they receive the same amount of sunlight in winter, but their winters couldn't be more different. And the reason why is a fascinating story of ocean currents and climate. In London, January brings chilly days, but nothing too extreme. The average temperature hovers around 5 degrees. Parks remain green, and snow is a rare sight. When it does fall, it's usually just a dusting that melts quickly. People bundle up in coats, but you'll still see joggers, cyclists, and families enjoying the outdoors. The city's rivers and ponds rarely freeze, and life continues with only minor adjustments for the season. Meanwhile, in Labrador, winter is a whole different world. Temperatures routinely plunge to 20 degrees or even lower. The sea along the coast freezes solid, and deep snow blankets the land for months. Houses are buried up to their windows, and daily life revolves around snow removal and braving the bitter cold. The landscape is stark, white, and silent, with only the hardiest wildlife and people venturing outside. So what causes this dramatic difference? The answer lies in the ocean. The United Kingdom is bathed by the North Atlantic Current, a powerful flow of warm water that travels all the way from the Gulf of Mexico. In contrast, Labrador is chilled by the icy Labrador Current, which brings frigid water down from the Arctic. The North Atlantic Current acts like a giant hot water bottle for Britain. It releases heat into the air, keeping the climate much milder than you'd expect for this latitude. Even in the depths of winter, the sea rarely freezes, and the air stays relatively warm and damp. Powerful westerly winds pick up this warmth from the ocean and carry it inland, spreading mild air across the British Isles. These winds are a key reason why the UK escapes the deep freeze that grips other places at the same latitude. In Labrador, the story is the opposite. The cold Labrador Current brings icebergs and frigid air straight from the Arctic. The sea freezes, the land is locked in snow, and the cold is relentless. Winters are long, harsh, and unforgiving. This striking contrast is a vivid demonstration of how ocean currents can warm or chill entire regions, shaping the lives of millions of people and the landscapes they call home. The ocean's influence is the difference between a temperate climate, where winters are mild and life goes on, and a subarctic one, where winter dominates everything. So next time you enjoy a mild winter's day in Britain, remember, it's no accident. The warmth you feel is a gift from the sea, carried across thousands of miles by powerful currents. Without the North Atlantic Current, Britain would be locked in a winter as harsh as the Canadian wilderness. The ocean doesn't just shape our weather, it shapes our way of life. The Gulf Stream is the UK's unsung hero, delivering tropical warmth across the Atlantic. Originating in the Gulf of Mexico, it races northeast, carrying more water than all the world's rivers combined. As it moves north, it releases heat into the atmosphere, especially in winter, fueling storms and shaping weather. By the time it reaches Britain, it's slowed and broadened, but still keeps our seas unusually warm. This warmth allows subtropical plants to thrive in Cornwall and western Scotland. Palm trees in Britain, thanks to the Gulf Stream. Our marine life, too, is richer and more diverse than in colder waters at similar latitudes. The Gulf Stream's embrace defines our climate and our landscape. How does a warm ocean make our winters mild? It's all about energy transfer. Water stores huge amounts of heat, releasing it slowly as the North Atlantic current reaches our shores. Heat moves from sea to air by conduction and evaporation, warming the air above. Prevailing westerly winds then carry this pre-warmed, moist air across Britain. Western coasts, like Cornwall and the west of Scotland, feel this effect most: mild, damp winters with little frost. As air moves east, it cools, so eastern UK sees colder winters and more snow. The difference between Penzance and Norwich shows how the ocean's warmth fades with distance. Our cloudy, mild winters are a direct result of this oceanic heat delivery. The sea is our silent, ever-present radiator. For millennia, the Atlantic conveyor has kept northern Europe warm and stable. Now rapid climate change threatens this balance. Melting Arctic ice pours fresh water into the North Atlantic, diluting saltiness and making it harder for water to sink. This weakens the AMOC, and recent measurements show it's at its weakest in centuries. If the current slows further, the UK could lose its oceanic warmth. Past climate records show abrupt shifts have happened before. Now, human activity is the trigger. We're tampering with a vital system, risking dramatic changes we may not fully understand. What if the Gulf Stream weakens further? The UK could face much colder, longer winters. London's climate might resemble that of Eastern Europe, with more snow and severe frosts. Summers could become cooler and drier, with shifting rainfall patterns and more droughts. Farming would be challenged, as crops and growing seasons change. Subtropical plants would vanish, and native species would struggle to adapt. Marine life and fisheries would be transformed by colder seas. The very identity of Britain's landscape and culture could change. In a warming world, Britain could paradoxically get colder. The ocean's balance is delicate, and its disruption could reshape our future. The sea is more than a boundary. It's the force that shapes our climate and way of life. The North Atlantic current's warmth has made Britain's winters mild and our land fertile. The contrast with Labrador proves the ocean's power. But this system is fragile, threatened by climate change and melting Arctic ice. A slowdown is already underway, with the potential for colder winters and disrupted agriculture. Britain's weather is inseparable from the story of the ocean. We are part of a global system where distant changes ripple to our shores. The ever-moving sea is a reminder of nature's balance and our responsibility to protect it.